Hello everyone, my name is Parag and welcome you all in my new video. And in this video I'm going to teach you something detail in part. This is part 1 of the design of one-way slab. Okay, so design of one-way slab is really very important for each and everyone civil engineer, because when we talks about some as code and some different parameters, at that time we have to provide all this parameter in a design of one-way slab, because the slab is really very important function of a building, function of the structural element of the our building structure. Okay, so here I have a numerical, and with respect to that numerical I'm going to teach you what exactly the how we can solve this numerical. Okay, so here you can see that the I already draw wait a minute I already draw this this one-way slab. Okay, this is these things what you are seeing over here. Okay, I'm not properly shaded that. Okay, I just show you these things what you are going to you see over here. Okay, these things is a thickness, okay, which is 0.23 mm thick. Okay, so now I'm going to read my numerical, and with respect to that we are going to solve this. Okay, so numerical is in such a manner that design a simply supported slab. We are going to solve a slab which is a simply supported. What does it simply supported mean? A slab, okay, we know that the slab is always having the uniformly distributed load, right, and it is simply supported. Okay, now so it is a simply supported slab, simply supported slab. Okay, so guys, this is what simply supported slab we are going to design in our this numerical. So simply design a simply supported slab panel for a hall of clear dimension 3 meter by 8 meter. Now 3 meter by 8 meter the dimension is given to us. What does it 3 meter is exactly mean? The LX, and 8 meter is nothing but called LY. Okay, so you have to take LX and LY in respective manner. That means it nothing but X multiplied by Y format. So remember, it is LX and multiply by LY. Okay, so in that way you can remember what exactly LX and what exactly LY. Okay, now supported on 230 mm thick brick wall all around. So this is what exactly the thick brick wall, 230 meter thick. Okay, and all over that the simply supported slab is rested. Okay, you can get that what exactly this thickness all about. Now the slab carries a superimposed load of 2.5 kilonewton per meter square. Now the slab which is having the load conditions. Okay, now I'm going to define you, I'm going to show you what are the load conditions. Handwriting is not so good, so please don't make any queries about my handwriting. Okay, I'll just make sure that my handwriting is going to be correct each and every time. Okay, so what are the loads are there? First load is the slab carries a superimposed load. So first is superimposed load. Okay, which is of 2.5 kilonewton per meter square. Okay, with the floor finish of 0.5. Second is nothing but floor finish of load is 0.5 kilonewton per meter square. Okay, use M20 grade of concrete and Fe415 finish. So we have to use M20 grade of concrete and Fe415 steel. Okay, now show reinforcement detail. Exactly, we have to show them the reinforcement detailing after the completion of this numerical. So we are going to solve this by limit state of method. Okay, and this is really very interesting topic. So let's start with the numerical. First of all, what are the given data this is what the given data we have right now. Okay, with respect to that given data we are going to solve the total numerical. Okay, so now how we are going to solve it? First of all, you have to determine the slab is one way or two way slab. How we can determine the slab is one way or two way? If the condition LX by LY condition, okay, from the LX by LY condition, if the LX by LY condition is greater than 2, hence it is mean that it is a one way slab. Like means the LX divided by LY is greater than 2. So if this condition follow, that is mean that this slab is one way slab. Like means the LX divided by LY is greater than 2. So if this condition follow, that is mean that this slab is one way slab. So if this condition follow, that is mean that this slab is one way slab. Like means the LX divided by LY is greater than 2. So if this condition follow, that is mean that one way slab. Okay, now we are going to solve this. What is your Lx is 3 meter, okay, divided by 8 meter. Okay, if we are going to solve it, so I got a value, sorry, uh, oh, I'm really sorry, it's not L by Lx by, it is Ly by Lx. I'm really sorry, I just make some more mistakes always. So please, it is Ly by Lx. Okay, Ly Ly by Lx. If it is greater than 2, then your slab is called as a one way slab. So it is for 8 meter, 8 meter by 3 meter. I'm really sorry guys. Okay, 8 by 3. So this is what exactly we got the 2.67. Okay, which is greater than 2. So this slab is called as a one way slab. Okay, so the first step is to define the one way slab or two way slab. Is all about this. If it is your slab is greater than 2 point, that means Ly by Lx ratio is greater than 2.62, so it is called as a one way slab. If this condition, that means Ly by Lx ratio is less than of 2, so it is called as a two way slab. Okay, now I'll also show you what exactly. Now consider this is what your slab. Okay, in the slab only this notification is given to that, so it means that it is a one way slab, this one way. Okay, if this notification is given in such a manner, like, so this notification is represented two-way slab. Okay, so this is what exactly all about the one way and two way slab. And now from this is what our step number 1, okay, which is I already make some mistake. Okay, no worry, not worry about this. Okay, so now we done about the step number 1. Now we are going to define the total length. Okay, what exactly length, that means the clear center to center distance of the support we are going to define. Now that means what is this. Okay, because this parameter is defined in different manner. Now I'm going to take one new page. Wait a minute. Now what exactly that, this is what your simply supported span, right? Okay, all over that, this is what your thickness, right? This is what all about 230 mm. Okay, this is what 230 mm, and this is what uniformly distributed. Okay, so now what we have to do, we have to calculate the center to center distance. So we have to determine the L. This is step number 2, which is nothing but called as a center to center distance of slab of support. Okay, sorry. Okay, so how we can determine it from this center to this center. Okay, so center to center, that means if this wall is having a 230, so this center, okay, so it is 230, right? So half of 230 we have to take. Okay, and we have to add all these things. Now the main thing is that what is this length? This length is 3 meter, right? We are talk in this manner. Okay, so we are taking the load in this manner, right? So this is length. What is the Lx we have is 3 meter, and this is what 230. Okay, right? So now what exactly this calculation is in this different manner is like the half of 230 and half of 230 is nothing but 0.23. So distance, that means the center distance is 3 meter plus the half of the both the support is 0.23. That means half of this and half of this. Okay, so this is 0. That means 3.23 meter distance is of the total length what we have to subject it. Okay, so this is what 3.23. So when we convert it into mm, so it is 3230 mm. Okay, so this is what length exactly what we have to use. Okay, now so this is what we got, the center to center distance of support for slab. I am going very slow for numerical because this is really very important numerical for you all guys. Okay, now after coming to this, we are this is our step number 2. This determination of Ly by Lx is 1. This is step number 2. Now we are going for a step number 3. Step number 3 is all about the assumption of depth. Okay, that means we have to determine the assumption assumption of depth, okay, from deflection criteria. I use IS code, okay, criteria, that is okay, that is from span depth ratio. Okay, so it is in such a manner, d equals to L upon, okay, basic value multiplied by mf, okay, basic value multiplied by modification value. Okay, so L what we got is a 3230. Basic value is we have 20 for one way slab, okay, multiply by, sorry, multiply by, this is not properly seen as a multiplication fact point, multiply by what is the modification value we take is as a 1.5. Okay, you see we do those value are this value is a 20 for a one way slab, okay, and this value is for the assumption. Okay, so when we got the d, that means we have to determine depth of the depth for a deflection criteria we have to determine. So it is in a formula is we got 107.65. okay, so 107.67 mm. Okay, so this is what exactly we got. So now up to this part, when we come for assumption depth of the deflection criteria, after that we have to go for the assuming the clear cover for 15. That means for a slab, okay, for slab we always cover the 15 mm. Okay, for slab we always cover the 15 mm clear cover. Okay, for slab we always cover the 15 mm clear cover. Okay, now after that, by after doing all these things, as you assume the 15 mm cover clear cover for the slab. Okay, why we are providing the clear cover to the slab? Because whenever the steel coming to the in connect with the atmosphere now, so the corrosion reaction may be start, and because of that the our steel get corroded fast. Okay, so after assuming the clear cover, okay, after assuming, okay, after assuming the clear cover, okay, I just write out the clear cover. Sorry, I am taking this video very lengthy, okay, but it is a requirement, okay, because if you watch only one video you can clear your all the concept. Okay, so it is what 15 mm clear cover I assume, and I assume, okay, I assume 8 mm diameter bar. Okay, these are the two bar. Okay, these are the 15 mm clear cover and 8 mm diameter bar I want to assume. Okay, so this thing, after using this thing I wanted to determine the depth. Okay, so exactly what depth we got, the depth, the formula is that the d you have plus clear cover, okay, clear cover plus 5 by 2, that means diameter by 2. So d is what exactly we got. The d is nothing but what we got as a 126. Okay, no, sorry, 107.67. what this d we got, that is which is called as a depth, plus 20 mm, that means what we take it as a 15 15 a clear cover plus diameter by, that means 8 by 2. So we got the diameter d. Okay, depth is called as a 126. Okay, 126.67. okay, v is equals to, we get round up as a 130 mm. Okay, now after that we wanted to take a small d. This is effective depth we have to take. So 130 minus what we take the clear cover is a 15 minus of 8 by 2 dia. So we got the small effective depth, which is nothing but 111 mm. Okay, so this is what exactly small effective depth. D is nothing but the effective depth. Okay, effective depth, and capital D is nothing but what, overall depth. Okay, so this is what d is the effective depth and capital D is the overall depth we got. Now after that we are going to define the effective length for a slab. Okay, and which is really very important. Sorry. Okay, now we are going to, this is our step number 3. In step number 3 we are going to solve the calculation for effective span. Calculation for effective span. Okay, the calculation for effective span, okay, the value whatever is the identification is given by in the form of LE. Okay, so this LE, what we have to determine, the formula for the LE is really very simple. Okay, it is a, sorry, I take the another color. It has a formula, that the first formula is LE equals to, okay, center to center distance, center to, wait a minute, center to center distance of support. Okay, so in nothing but it is a clear span clear span plus width of support. Okay, so this is what exactly it is. So the clear span is what, the LX plus BS. Okay, so LX is nothing but what we have, the 3 meter, plus BS is nothing but 0.23. The width of the support we know, because this is what the width support and this is what the width. Okay, 0.23. Okay, the clear span we know, the 3 meter, so the value is 3.23. This is what the one effective depth. Okay, this is what one effective depth we got. Okay, where it is, yeah, this is what is one effective depth we got right now. Wait a minute. Actually I solved one on my one paper, and from that I just came to the all the data. Okay, next one effective, that means second formula for a effective depth. This is what the first simple one formula. Next formula for the effective cover is in such a that clear span, okay, clear span plus D. So what is exactly the clear span? Clear span is nothing but the LX plus depth. Okay, so LX is nothing but the 3, and okay, and the what we depth find out right now, 111 mm, so we are just add over there, so 3.111 mm. Okay, so this is also one value. Next is what we have to do, we have to take the smaller value of 2. That means if you take the LE of the smaller one, or take LE of the smaller one, 3.111 and 3.23, comparatively though this value is really very smaller. Okay, so we take LE as a smaller value of the 2. Okay, so it is as 3.111 mm. Okay, so now we got the effective length, sorry, really sorry. Okay, now we also got the effective length. Okay, we also got the effective length over here, it makes somewhat mistaken. Okay, so okay, so we got LE right now. Okay, after that in next video, this is all up to my part number 1. In part 1 we now discuss up to the, I'll just remind you what we learn over here. Okay, we learn the what is a basic parameter, what is a ratio which define the one way slab or two way slab, and after that one way and two way slab definition we are going to define the length, that means the distance from support, then we get assumption for the T, then we define the clear, assume the clear, this is for assumption actually. Okay, this was assumption for the clear span. Okay, and after that we go for the calculation for the effective span of LE. Okay, and this is all up to this. Please visit my website, okay, which is listed, which shown in the video at bottom. Okay, and don't forget to subscribe and subscribe my channel and like my video. Please like and subscribe my channel, because I need your help guys, because as you help me a lot, I'll be help you too. Okay, so thank you, and please watch this video continuing part number 2. Thank you.